Good morning, ladies and gentlemen. I am Wilhelm. I'm presenting this talk on plant health as part of the NSTF Plant Health Discussion Forum. I'm going to talk to you today about a tiny beetle that's having a big impact in South African forests. And before I start, I have to define what I mean with forests. Now, I include in my definition of forests, natural forests, from down in the Tsitsikamma, right up to the Kruger National Park, also commercial forestry plantations like this one in KwaZulu-Natal, or commercial orchards, fruits and nuts, this one in the commercial in the Northern Cape. Then it includes these lone shade trees on farms in the Karoo, champion trees on big estates down in the Cape or other places, urban forests like this one in Johannesburg, which is famous for its massive tree canopy, botanical gardens in our cities, also these beautifully landscaped environments that we find now on the periphery of our cities, but also normal garden trees and street trees in our cities. Like this beautiful lane of plane trees in Pietermaritzburg, where a colleague of mine, Dr. Trudy Paap, found this beetle for the first time in 2017 while she was doing routine surveys as part of a big international project that we refer to as the International Plant Sentinel Network. Now, both our institute, FABI, as well as SANBI, are involved in this survey that's being done in the botanical gardens across the country. What Dr. Paap saw on these trees are something look like gunshot wounds, and these make little cankers on the stems of the wood. And if you look a little bit closer, you will see an entrance hole as well as some streaking when you remove the bark. And this streaking is caused by a fungus that can eventually kill the tree. But if you look in the little hole in this streaking that you see here, we will find a couple of beetles, and as you can see with the tip of a toothpick here, these beetles are really tiny, 2 millimeters in size, with a little male to the right, which is even half the size of the females. So this beetle she brought back to our laboratories in Pretoria, and we looked at it under a microscope, but as we typically need to do with these beetles, it's quite difficult to distinguish them from each other and put a species name on them without or with only a microscope. So we also have to do DNA sequencing. So we take DNA from the beetle, we determine a sequence, and then we compare it with sequences from other studies in other parts of the world that is available in online databases. And through an analysis that we refer to as a phylogenetic analysis, we can then see where this beetle fit and what species it is. In this case, at the top of this phylogenetic tree, you can see some blue text. This is the beetle that we found in South Africa, and it turned out to be Uvulaceae fornicatus, or commonly referred to as the polyphage shottle borer. Now, this beetle is part of a species complex that is referred to as the Uvulaceae fornicatus species complex that consists of 4 beetles, and 3 of these species are already invasive in various parts of the world. And it is important that we can distinguish between these species because they carry different species of fungi with them. So if you look at this gallery or these tunnels of the beetles in a piece of wood, if you open it up, you see that the tunnels are lined with a dark stain, but you will also find some eggs, some larvae, some adult beetles in these tunnels. But if you take a microscope and you look at these lining of the tunnel, you will see that there's a fungus growing, and this fungus is the food of the beetle. The beetle actually carries its crop with it. It cannot digest wood, but it makes its gallery in wood, and there it cultivates its fungus garden, which then serves as its own food. But it's very specific and picky as to what fungus it carries. And in this case, We also isolated the fungus from the galleries that Dr. Prof brought back from Pietermaritzburg. You can see the fungus growing in a petri dish here. And then we do the same thing as with the beetles. We isolate some DNA, we do a comparison, and in this case we found again that the fungus was exactly the same fungus that is carried with the beetle in other parts of the world, and I will say something about where it comes from just now. But if you look at the fungus inside the wood, on the left-hand side, the longitudinal section, on the right-hand side, the transverse section of the tree, you can see that the fungus is staining the wood. This fungus is growing in the living part of the tree. Eventually, it can block up the vessels of the tree, and it actually can kill the trees. We refer to this as a vascular wilt disease. So eventually, this tree might die. So on the right-hand side also you can see the branching tunnels of this beetle, which means the beetle is reproducing and very active inside this tree. So this tree becomes its home, and the tree might die over a period of 5 years, a slow death, but the beetle is very actively reproducing in there and building up its population and becoming more and more in a specific environment. Now the polyphage shuttle borer is not very well known to science, and the reason for this is it was described initially from Southeast Asia, but there in its natural ecosystem it doesn't really do any damage. With its checks and balances in its native ecosystem, it is sort of, the trees have got resistant, there's some measures of control, some fungi, some other insects that control it, but when such a beetle is taken out of its environment, it can become very damaging. Now, it was first found in California in 2003 and in 2008 in Israel, and in both these countries it really started causing a lot of damage, and specifically on avocado trees, but also lots of other tree species. Although we found it for the first time in 2017 in South Africa, in retrospect, we actually found a DNA sequence in an online database that was part of an eyeball project where the beetle was detected already in 2012. Unfortunately, it was just never reported to anybody that's knowledgeable about tree insects and diseases, so we missed this opportunity to actually start working on the introduction in South Africa. Now in California it really caused a lot of damage, and there's quite a substantial body of research that has been done in the States. Here you can see a link to the Californian webpage. On that page of the University of California, you will find updated information of the outbreak in California with living maps, but then important also lists of tree species, and we refer to these as host trees. Now, there's different groups of species that we put these trees into, or different categories. We refer to reproductive host trees, which is what I just talked about, where the beetle actually infests the tree and successfully breed and multiply within the tree. Most of these reproductive host trees will eventually die. Non-reproductive host trees are the majority of the trees on these lists. This beetle is very brave, and it really attacks any type of tree that comes in its way. Sometimes it actually succeeds in penetrating the bark, going into the sapwood, but then for some reason it doesn't like the environment, it might leave again. Sometimes the host response of the tree is so strong that the beetle gets trapped in resin. That is the tree's way of defending itself. The beetle dies. But the fungus gets in, so the fungus can actually start causing a little bit of disease in this tree, but typically the non-reproductive host trees don't die in the end, so they will show some symptoms, but they will recover. And then, of course, there's the trees that doesn't get infested at all, and those are the trees that is important to us, because we need to now start planting trees in the place of the dead trees. So we are looking for resistant tree species that we can plant in this place. But what is unique about this beetle is that it goes for so many different tree species. Typically, insects of this nature would go for one group of trees, eucalyptus trees or pine trees. this thing just goes for everything that comes across its path, and it really tries everything. And also quite a lot of different ecosystems. In South Africa to date, we have found this beetle already on more than 130 tree species. 45 of these are native tree species. And of the 130 species, there are 25 reproductive hosts, which means the beetle can reproduce and eventually kill these trees. Now, not nearly all these trees are going to die. There's a small number of trees that are really at high risk. The problem is, however, with our native species, we cannot predict. This beetle doesn't follow any patterns. It just goes for mature trees of any species, and we don't know what's going to happen. Now, an updated list of this species, as we find the beetle on more species in the country, is presented on our website with the URL presented here. The problem with listing these hosts is that within a species, there is also variability in terms of resistance to this beetle. For example, jacaranda trees are not typically susceptible to the beetle, but occasionally you might find a stressed jacaranda that's got some other underlying stress factor, drought or damage to its roots or whatever, that might get some infestation. But in general, 99 out of 100 jacaranda trees do not get infested and doesn't get the disease at all. So although jacaranda might make, the name of jacaranda might make it to the species list because we found it in jacaranda, it doesn't mean that all jacarandas are at risk. So these lists also need to be interpreted with care. We cannot just accept that all the species on this list are at high risk. So the big question is then, how did this thing come into South Africa? Now there's different pathways, but typically these types of insects and diseases are spread with wood that is not treated properly across the world. Now in the background here you can see the routes of trade ships across the world. You can see quite a thick line of ships making its way past South Africa or towards South Africa from Southeast Asia. So we are pretty sure that this beetle came into South Africa on a ship, most probably with dunnage, which is the pieces of wood on the bottom side of the slide, which is used to wedge in between containers and stuff. This is typically just offcuts, untreated pieces of wood, which is really a good harbor for these insects to hide in while they're on the ship. The same thing goes for pallets. Pallets are typically made of low quality timber. They're supposed to be treated properly, but very often they're not, and these beetles can survive in these pieces of wood. In the local environment, so this is how it spread with the ships on long distances, but in short distances in our cities, the biggest risk is, and please ignore the telephone numbers on this slide, these are not culprits, these are just photographs that I took from across the country, where tree fellers, people that cut down dead or dying trees in the cities, are unaware of what is inside that tree. They move these pieces of wood to dumping sites, or some people go and sell it for firewood, and in that way the beetle is being spread. And we've got a beautiful example of a tree that was cut, a maple tree in Sandton, and 30 kilometers north of Sandton in Lanseria, a person bought a bucket load full of firewood, and somehow we heard about this and we went there, and this firewood was infested with these beetles. So from a single piece of firewood I was able to get 44 mature living females with 5 males, the little small ones on the right, and on average these females can lay 32 eggs, which make for 1,408 babies from a single piece of firewood, and there was a whole pile of firewood. We arrived there 3 weeks after the wood was dumped, and already the oak tree just next to the dumped wood was heavily infested with the beetle. So with a single bucket load full of wood, there was now a new outbreak in a new area which hasn't seen the beetle before. Another way in which the beetle is spread is it can move from one reproductive host tree to the next one. So the beetle can fly about 1.5 kilometers at most. So it cannot fly that far. But in terms of management, castor bean, for example, is a big weed problem on many farms and forests, commercial forests in the eastern parts of the countries. Now you can see these green patches among the sugarcane here. Sugarcane can serve as a buffer, so the beetle cannot cross there, it cannot infest sugarcane. But if there's patches of castor bean, it makes these little islands for the beetle to travel from one patch to another, and in that way the beetle can advance. And we're actually seeing that. So this is just what castor bean look like where it's infested, and it is strange. It's a small tree. Typically the beetles go for big trees, but in this case it really reproduces quite successfully in this weed. Another way is in freshly cut wood chips, although this is not such a big risk. Some beetles can survive in it, and fresh wood chips is quite fashionable at the moment, and we have found the beetle in chip plants in South Africa already. The other problem is nursery stock, where trees in bags are being sold and moved across the country. Although we have found nursery stock with infestations, to date we haven't found any beetles reproducing in nursery stock in South Africa, but that has been found abroad and it needs to be monitored. We need to watch out for those. So in terms of impact, the beetle is having a massive impact across what we refer to as different sectors in terms of commercial, agriculture and forestry, in our natural forests, but also in our urban areas. And the urban areas is really where we, at this point, see the biggest impact. It's most visual. So let's look at what's happening in our urban forests. So this includes streets, trees, parks, and gardens. This is Lovat Road in Johannesburg, and on our first trip to Sandton, when we were informed that the beetle was present there, this is what we found, a whole street of maple trees that was already dead at that point. If we looked at some of the cut trees at the base, we could clearly see the signs of this beetle's infestation. If I went back onto Google Maps 5 years earlier, this is the exact same street with these trees. So within a matter of 5 years, all the trees in that street of this particular species were killed by the beetle. This is one street down in George in the Southern Cape. English oak trees are very susceptible to this beetle. 47 big dead oak trees in one street in George has to be removed. This is very costly. The beetles reproduce big time in these oak trees, and the whole area become infested. And the more beetles there are, the more they're trying different host species or different host trees in the environment. So it is important to remove these infested trees while they're still standing there and while the beetles are reproducing in them. This is a beautifully sculpted landscape in Fancourt on the periphery of George, and you can already see oak trees dying there. Fancourt has done an amazing job at taking our advice and removing heavily infested oak trees. They have spent millions of rands on that, but already has started replanting, even before they started cutting trees, replanting with resistant species against the beetle. Removing a big tree like this is very costly. It can be anything between 5 and 30,000 rand, depending on where the tree stands. So you can imagine that the costs of just removing these trees are immense, and these have to be carried by municipalities when it's street and park trees in cities, but when it's in people's private gardens, people have to pay for this, and this is quite a lot of money. So people very often rather leave the tree to die, and that becomes again a problem because the beetles start reproducing in that garden, and it can just become a source of beetles into the environment. Now, people often talk about Joburg's urban forest. This is what Pretoria looks like in summer. It's really a big forest. So we have found the beetle for the first time in Pretoria around the zoo area. On this map that you see here, right in the middle towards the top, there's a green patch. That is where the union buildings are. The zoo is where the outbreak started. This was in April 2019. We surveyed the area around the zoo, and a few trees outside the zoo were already infested. Now, the beetle has spread to several suburbs around this area, and it's moving eastwards, and it's moving down streets with susceptible hosts, and these are particularly in the Pretoria environment, London plane trees, and then also Chinese maple and box elder trees. And we're starting to see trees dying. So this is, for example, trees just outside, London plane trees, just outside the union buildings in the back there. We, for the first time, found the beetle in the gardens of the union buildings in April 2021. On the right here is Dr. Trudy Paap with a team of government officials looking at these infestations. So we're working together with local government, but also provincial and national government in trying to come up with some management strategies for this beetle. In agricultural crops, this is usually where these types of pests are being dealt with the fastest and the easiest, because there are very good systems in place to deal with these type of introductions. And that was also true in South Africa. The moment we found out the beetle is here, we informed the avocado industry and some of the other tree crop industries, and people started to look out for this thing. Luckily, until this point, we haven't found the beetle in any commercial orchards, except for pecan orchards, strangely enough, in the very arid northern Cape, in the Hartswater area. This was in July 2017. Now, 2-3 years on, we know that the beetle is actually not killing pecan trees. It infested, but eventually the pecan tree heals up. The beetle doesn't reproduce in pecan trees, which was good news for the pecan industry. So we worked on a project for 2 years with them, funded by them, to actually just determine the risk for the pecan industry. The problem is, on farms, there are other host trees, and this one is an oak tree on the yard of a pecan farmer in the Northern Cape. This oak tree was heavily infested with the beetle, and it became the source of beetles into his own pecan nut orchards. If you look at the background of this oak tree on the left, you will see in the distance some pecan nut orchards there. So this farmer did the sad but right thing here. He cut down 7 big oak trees that his grandfather planted on their yard to save his orchards. Now he's got 1 acacia tree left on that yard. It's really sad to see these things happening. Avocados are one of the biggest risks to date. We're working closely with the avocado industry. We haven't found it in avocado orchards, but we have found it on several avocado trees in people's gardens. And on the left you can see, we call these sugar fountains. The symptoms on the avocado trees are quite visible. The sap that oozes out crystallizes and make these white spots on the trees. If you open up, you see the tunnel going in, and you see the streaking of the fungus. In terms of commercial forestry trees, and in this case in South Africa, we have pines, eucalyptus and wattle trees that are planted commercially. Luckily, this beetle doesn't attack pine trees. It seems not to like the conifers particularly. We have found it on some eucalyptus trees, but very few infestations, not causing any damage. But we have found it also on wattle trees, or Acacia mearnsii, but again, not in plantation areas, but in roadside weedy wattles that was heavily stressed. So to date, we haven't seen it in any commercial plantations anywhere in the country, but we're working closely with the industries to monitor what's happening, because it's bound to change. This beetle is spreading, and we're going to see it eventually in some of these areas. In terms of native trees and natural forests, this is where our biggest concern is, and also it's also the biggest unknown. We cannot predict what's going to happen with our native tree species. The first native trees that we found it on was actually garden trees in Johannesburg. In this case, paperbark thorn. Some of the trees actually eventually died. but in the same street some other paperbark thorns didn't even get attacked at all. So again you have this discrepancy within a single species. Not all paperbark thorns are going to die, but some of them are. Erythrina, the beautiful coral trees with the red flowers, is also susceptible. They have seen some South African erythrinas being killed in botanical gardens in Los Angeles, and we have also seen it here. But again, not all erythrinas are going to die. We're trying to understand what the contributing factors are that leads to death. So we have these big survey projects going on at the moment down in the Southern Cape, but also in the KwaZulu-Natal area, where we're monitoring the spread as the beetle is now moving into our natural forests, and also the impact on all the different tree species there. This is a massive undertaking, and we're already starting to see a picture. The good news is we don't see big parts of the forest dying. This beetle attacks, as I said, a lot of trees, but individual trees might die. The big risk here is that a keystone species to a forest like Virgilia species is quite susceptible, and if the beetle removes that from the ecosystem, there's going to be a shift in the ecosystem. There's going to be a change in what is happening in that forest. And that is what we are concerned about. This is something we just don't understand yet, and we don't know exactly what is going to happen. So in terms of the spread, this beetle is now everywhere in the country. We just don't have confirmed reports from Limpopo yet, but personally I think it's there. I just don't think we've detected it yet. It's in all the major cities. It's spreading in Cape Town. It's actually spreading northwards from Somerset West, where we found it for the first time in April 2019, I think. And it's now crossed the hill in Somerset West, and it's moving towards the wine farms, where it's going to definitely kill a lot of English oaks, and towns like Stellenbosch. The landscape is going to change. Those towns are going to look very different 5 and 10 years from now, and they actually will have to start already planting different tree species than just the oaks. Really sad. So the big question is always in terms of, so what do I need to do? What if I found the beetle on a tree in my garden? What do I need to do? From the municipality point of view, if they found it in street trees, what do they need to do? And it's strange, people come up with all kinds of weird ideas about how you can deal with this, and obviously there's also some opportunists that want to make money out of this. But at this point, the unfortunate reality is that there's not much you can do in terms of healing a tree or reducing the infestation on a tree that's already infested. The beetle goes quite deep into the wood, and it cannot really be stopped once it's in. There are some experimental chemical controls happening. Those are expensive. They need to be repeated over time, and it's simply not doable on a large scale. So in terms of an individual tree in your garden, if you have the money to repeatedly treat this tree, that can be done. In South Africa, there is no formally registered chemical products at the moment for treatment of these trees. There's one that's being provisionally registered. This company still have to produce more data to get it permanently registered. But in the meantime, management is really, really important. And the big thing is, as I mentioned already earlier, when there's a tree that's heavily infested in which the beetle is reproducing, the best thing is to remove that tree from the environment. Cut it down, but the important thing is then what do you do with that wood? Do you just go and dump it somewhere? Then you just spread the beetle. So that wood has to be treated. We talk about solarization, where we actually cover the wood with plastic, leave it in the sun, preferably on the site where the tree was cut. We leave it in the sun for a couple of months, and the beetles inside will die. Or the wood can be chipped, and then preferably also composted on site, where you put it in a pile, cover it with plastic, leave it there, so that any remaining beetles in there will die. In terms of what do we do towards the future, we need to diversify our urban plantings, and with that I mean we need to move away from this idea of beautiful streets with a single tree species going down the streets. It's beautiful, we've seen it in many places, where this beetle then actually just takes all the plane trees in that street and kills it. On the bigger picture, in terms of climate change, that is also a problem if you just have these monoculture streets of trees. So the big advice here to cities is to diversify, to move away from the idea of patches of single species, but rather mix different species of trees in any particular environment. That will make that environment more resilient. Of course, people are very emotional about their trees. If they've got a big, beautiful tree in their garden, and you come there and it's a plane tree or an oak tree and there's lots of beetles in, they're going to try everything to save that tree rather than to remove it. What we're trying to tell people is, please, you're doing yourself and the whole community in your area a disservice by keeping that tree. And if you have some emotional attachment with that tree, our recommendation is take some of that wood and make something with that tree so you can remember it here. And you see on the right here a set of earrings. I had a jeweler manufacture a set of earrings for my wife for a present for one Christmas of an infested maple tree, just to show that you can be creative and you will have a memento of your tree forever if you do something like that. Or get a carpenter to make a piece of furniture. The wood is still usable, it's just going to have these tiny little holes in them, which actually makes an interesting story. From the government perspective in the country, in terms of control and management of an invasion like this, this particular example was really problematic. And the reason for that is because it's everywhere on everything. As I said, in 3 different sectors, commercially, gardens, natural forests, and all these are governed by different government institutions. And initially it was really difficult to get together these stakeholders, because typically different government departments work in silos, they don't really communicate to each other, and it was a major challenge to actually get the people together. I'm particularly thankful for Dr. Stewart Christie, who came up with a national strategic framework, a document which is available on our website, which has been presented and accepted by government to guide government in terms of management of this process of dealing with the invasion in the country, to bring together different government departments and institutions to come up with a national strategy to deal with this problem. In terms of research in the country, many academics and universities are involved. I think at this point 7 or 8 universities, many different projects running. The list of projects is also available on our website. We refer to this network of researchers as the PSHB Research Network. And we've got projects in the agricultural sector, we've got projects funded for natural forests, and most recently also City Parks funding a project in urban forests. So that is the first project that we have where we actually have funding to look at the problem in urban areas. But there's a long way to go, and a lot of more work needs to be done to really deal with this problem. But to summarize in the end, the impact of this beetle, what is going to happen, what is happening. The good news is that not all trees will die. We're going to see especially city landscapes changing. Most of the trees that are most susceptible at this stage are exotic trees. So we can replant, and this can be done. This is manageable. In terms of agriculture, it's also a manageable problem because we're dealing with the industries. The industries have very good communication with their farmers and companies, and they they have strategies in place to deal with this. In terms of the natural forests, that is where my biggest concern is. In the end, it's unpredictable, and only time will tell us what the impact is going to be. But the fact that there's going to be some native trees dying and some changes in our ecosystems, we cannot dispute. We are a big team of people. This is only a few of the people working across the country on the problem. There's a lot of information available in terms of color brochures that's funded from different sources on our website. So please, if you need more information, this is the place to go. There's also contact email addresses that you can do inquiries towards and ask questions if you need to. Thank you very much.